Hey guys, welcome back to our last set of notes for chapter 15. We're looking at the acid-base properties of salts here for our last part. We'll start with neutral solutions. If your salts contain alkaline metals or alkali earth metals except for beryllium and the conjugate base of a strong acid, they're probably going to be neutral. So here we have sodium chloride, salt, with water. You always assume our salts are dissolved in water and that they're completely dissolved. Makes sodium ions and chlorine ions. Sodium ion's pretty big. It doesn't ionize in water. Chlorine ion, if it did react with water to make HCl, we'd be making a really strong acid. That strong acid would go right back to the conjugate base chlorine minus. And so we're really just going to have chlorine. We're just going to have sodium. We're not going to have excess hydrogen ions, so it's going to be pretty neutral. If we're looking at basic solutions, those could be salts that are derived from a strong base and a weak acid, which is kind of weird to think about that, but strong base, basic solution, sort of makes sense. And so here we have NaCH3COOH dissolving it in water. Sodium is dissolved, and so is CH3COO minus ion. Sodium again, big metal, doesn't really change anything. But if you look at this guy here, you try to figure out, well, what is its conjugate acid? And what does that look like? So we say, okay, if we took this and reacted it with water, we'd make CH3COOH plus OH minus. And so here's our base reacting with water, creating OH minus. And so we probably will create a little bit of OH minus there, and the solution will be just a little bit basic. So what if it's acidic? If your salts derive from really strong acids and weak bases, then it'll probably be acidic. You'll want to refer to those tables we've been using quite a bit for Kas and Kbs for strong acids and weak acids and bases and things of that nature. That'll help a lot for this. Take your salt, split it in half, assume you're in water, and say, okay, how would NH4 react with water? How would chlorine minus react with water? We've talked about chlorine minus already. It'd make hydrochloric acid. Hydrochloric acid strong, and we'll immediately go back to HCl. But NH4 plus could react with water. NH4 plus normally will become NH3 and H plus if it's in an aqueous solution, which it is when it's dissolved in water. And so if it's going to do that, it's going to make our solution rather acidic. So some of our really small salts that have really highly charged metal cations, these will include aluminum, chromium, and beryllium, and the conjugate bases of a strong acid. They can also give us some pretty acidic solutions. Here we have, what would this be? Let's see, aluminum hexahydrate? Yeah. 6. Yep, hexahydrate, yeah. Goes to this compound here and the hydrogen ions being removed from it. And so it's a highly charged metal cation, aluminum 3+, and it's going to react with water to create hydrogen. And here's kind of what that looks like in a sort of three-dimensional model here. Water comes in, steals one of these hydrogens off of one of the water groups on aluminum, and becomes H3O+. That's all it takes to make an acid. So, what if both our cation and our anion will hydrolyze in water? That can get a little bit tricky. What you'll do is you want to find the Ka for your acid, the Kb for your base. If the Kb is bigger than Ka, it's going to be basic. If the Kb is smaller than Ka, it'll be acidic. And if they're about equal to each other, well, our solution